6.1 is a review section. We did look at this, right before school got out 3 weeks ago. We're going to review it again, and then I will open up the assignment and big ideas. But let's go ahead and work our way through relations and functions. Now, relations just tell me how one set of numbers is related to another set of numbers. But a function is a very special rule that tells me how an input can get me an output. And we've looked at functions with mapping diagrams. But like I said, a function is a rule that takes an input and maps it to an output. Maps means correlates with. If I have one input, it gets me one output. And so each input has only one output. That is a fundamental rule of functions. If I put 5 into the function machine here and I got out 8 or -8, that would not be a function because I got 2 outputs from one input. But this is like the idea of a function. I put in some number, I get out some other number, and so in this case, if I put in 5 and the function machine just says add 3, 5 maps to 8 because when I put in 5, I get out 8. 6 would map to 9. 7 would map to 10, right? All I'm doing is whatever I put in, add 3, get out 8. Now, not all rules are this simple, but this is a function. And says, what is the output for an input of 12? If I put in 12, I'm going to add 3 to it, and I will get out 15. This right here is showing me how an input maps to an output. Then, here's another example. A mapping diagram and a function rule. So the output of this is supposed to be the area. The input is the base of the rectangle. Of course, the height of the rectangle is 8. So how do I calculate area? Well, area is equal to base times height. In this case, that means the area is equal to 8 times x. So our rule here is take the input, x, and multiply it by 8. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. Right? So this is a function because every input maps to one output, and this mapping diagram tells me how the input is related to the output. Because we are taking one number and relating it to another number, we could write this as an ordered pair. And when we write it as an ordered pair, we let our inputs be the x's and the outputs be the y's. So it becomes an ordered pair of 1, 3, 2, 6, 3, 9, 4, 12. This is a function because one input maps to one output. This, on the other hand, is not, and let's see why. 0 maps to 0, that's fine. So we have an ordered pair 0, 0. 2 maps to 1, but then 2 also maps to -2. So this is one input, 2 outputs, and that means this is not a function. I can still write that ordered pair, but it's just not a function. And then I have 4, -3. So because this 2 also mapped to 1 and -2, we have not a function. You can only map to one thing in order to be a function. The mapping diagram still shows how these numbers are related to those numbers. And then one final example here. It says, consider the mapping diagram below. Here's the input. There's the output. Determine whether the relation is a function. Well, every input has one output, so that's good. So yes, it is a function. It is a function. And then it says, describe the pattern of inputs and outputs in the mapping diagram. Well, there's a pattern here. Every time we changed our input, we went up by 1. But that doesn't relate it to the outputs. Every time these outputs went up, we went from 36 to 48. That went up by 12. 48 to 60 went up by 12. 60 to 72 went up by 12. But if I'm actually relating the inputs to the outputs, I can see that if I take 3 times 12, I will get 36. 4 times 12, I will get 48. So describe the pattern of inputs and outputs. I would say the output is input times 12.